everyone. Teacher Dolly here. Welcome back. If you're new to my channel, please subscribe and click the notification button. In today's video, we're going to discuss displaying the outcomes of two events in an array. And that's one of the lesson objectives. And then find the probability of two events occurring. So let's go to the basics of theoretical probability first of all. So we're going to consider here just single events. So first one, that's tossing a coin. And what are the possibilities? We have a head and a tail. So if we're going to get the probability of getting a head, it's 1 out of 2 or 1/2. That is in fraction. We can write it too in another format, and that is in decimal. And yet another one you have in percentage. So it means to say that a probability can be expressed in fraction, in decimal, or percentage. Now let's look at the next single event, which is very familiar. So we have a rolling a die event, okay? So die is singular for dice, so I'll take it as rolling a die. So you have the possible outcomes is 1, 2, 3, 4, or 5, or 6, okay? So what is the probability that the number that you will get would be less than 5? So looking at the possibilities here, we have 4 of them. So 1, 2, 3, 4. So that should be 4 over 6 as the probability. And reducing that to simplest form, we have 2 over 3. All right. Formula for theoretical probability, you have number of ways the outcome can happen divided by total number of outcomes. Now, let us consider at this point two events occurring. So two events occurring, we have, say here, an example, rolling 2 dice. So we are going to find the probability of getting a total of 6. First of all, we need to show or to represent the sample space of these two events. And we can do that by drawing a table. So that's the table, dice 1, and you have probabilities or the outcomes 1, 2, 3, 4, 5, and 6. And dice 2, we have 1, 2, 3, 4, 5, 6. So if we get 1 in dice 1 and we get 1 in dice 2, the total would be 2. 1 in dice 1 and 2 in dice 2, you have a total of 3. So we have 4, 5, 6, 7. And then you have 2 and 1, that's 3. 4, 5, 6, 7, 8. 3 and 1 is 4, 5, 6, 7, 8, 9. Then you have the total that we get would be as follows. All right, so now that we have represented the sample space in a table, it's easy now to get or to answer the question, probability of getting a total of 6. So we go back to the sample space and find out how many totals of 6 are there, okay? So that's 1, 2, 3, 4, 5. So there are 5 probabilities or possible outcomes over 36. All right. Now, let's have more questions. The probability of getting a total that's even. So the even numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 divided by 36, which is the total of all the outcomes, or 1 over 2. Another one, you have total is greater than 9. So greater than 9 are these numbers, 10, 10, 10, 11, 11, and 12. And there are 6 of them. So we have 6 over 36, or 1 over 6. Next one, we have a total that is less than 6. So all of these are less than 6 and equal to 10 over 36, or 5 over 18. Okay? Then the last one, the probability of getting a total of 1. So checking on the sample space here, do we have a total of 1? There's none. Therefore, that is equal to 0. All right, let's take the second example. So question, what is the probability of getting the same number if you spin the spinner twice? Let's have the spinner there. The possible outcomes are 1, 2, 3, and 4. Before we can answer that question, we need to show the sample space in a table. So we have that table. First spin, we have 1, 2, 3, 4 possible outcomes, and second spin, 1, 2, 3, 4. So if we get 1 on the first spin and we have 1 on the second spin, then we have a 1-1 result. So 1 on the first and 2 on the second, we have a 1 and a 2, and so on. 3, okay. All right, so we now have completed the sample space. Now, how many outcomes are there? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 outcomes. Okay, now we can answer that question there. How many did we get that are the same number? Okay, so we have 1, 2, 3, and 4. Therefore, the answer to this question should be 4 over 16. Or you can reduce that to 1 over 4. All right, now let's have more questions. You have the probability of even pairs. So we'll look at the sample space again and look at the pairs that are even. So 1, 2, 3, and 4. So you have 4 over 16 equal to 1 over 4. Okay. Another question, the probability of getting two numbers that are not the same. So we have are not the same would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is 12 over 16, or 3 over 4. All right, that ends the video for today, and I'll see you in the next video. Bye for now.